Hi, this is Guillermo Campitelli, and I'm going to talk about probabilities using the drone delivery metaphor. Now, typically in textbooks, probability is explained using other metaphors. The dice, coins, roulette. These are typical metaphors that are used to explain probability. And the beauty of these metaphors is that they allow for repetition. We can throw the dice several times, we can flip the coin several times, we can play the roulette several times. And so these are useful metaphors to understand probability. There's nothing wrong with these metaphors, but they give an idea that in order to understand probabilities or probabilities are about things that repeat on time. And this is actually one version of one view of what probability is, which is the frequentist view. But there is another view, the Bayesian view, that uses aspects of these metaphors, but I think they have another conception of probability that is not captured by these metaphors. So that's why I'm going to use a new metaphor to explain probabilities. Now, this metaphor is about a city, we call it Z, and there is a pizza shop in the city which delivers pizza using a drone. So the drone will come, some will land somewhere in the city. Okay, so we know a little bit more about that city. The city is classified into regions based on some criteria. One of these criteria is the age of the region, and actually there are two regions based on the age. One is called the old region, which is this striped area, which covers 60% of the city. It has 600 square kilometers out of a total of 1,000 square kilometers. And the new city, which is the plain area, or represented by the plain area, is 400 square kilometers. So it's 40% of the whole city. Now, the city can be also classified according to another criterion, which is the location. So 500 square meters are considered coastal areas and are represented by blue in this graph, and 500 square meters are inland areas and are represented by yellow in this graph. Now we can have a combination of these two criteria, and the city will be classified into 4 regions. The old coastal region, which is the blue striped area, and covers 400 square kilometers or 40% of the whole city. The old inland area covers 200 square kilometers or 20% of the city. The new inland area covers 300 square kilometers or 30% of the city. And the new coastal area, 100 square kilometers or 10% of the city. Now we can use this knowledge about the land of each region to try to understand probabilities. Now, we are going to use to make some assumptions, and the assumptions are that people in this city will call the pizza shop and they will request a pizza, and the preference of people regarding pizza is the same. So the people in all the regions, they have the same preference of pizza. The other assumption is that the number of inhabitants in each region is proportional to the size of the region. So basically here we will have 40% of people living in this area, 20% of people living in this area, 30% of people living in this area, and 10% people living in this area. So the question is, let's say the first time the shop makes a delivery, it receives a phone call, and we observe that the drone comes with the pizza and it will land in one of these areas. So the question is, what's the probability that the first landing will be in some of these areas? Yeah, so that's the what we are going to try to understand using this metaphor, and it's actually very, very simple. Okay, so we can ask many questions. We can ask, for example, what's the probability that the first landing will be in the old area? And here I'm going to explain a little bit of this notation. So this vertical bar and the letter K, what does it mean? Okay, the letter K means background knowledge. And because all probabilities are conditional on something, some assumptions, some knowledge that we have. And here there is the knowledge, for example, that the drone will land somewhere in the city. It will not land outside the city. So we make that assumption. That's background knowledge. If we don't make that assumption, then the numbers we have here are not correct. Another assumption is that the drone will land in one of these four regions. It will never land in two regions at the same time. So it can land here, 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 or there, but never in both. And it will not land half in the city and half not in the city. So these are very important assumptions, very easy to follow, but the probabilities that we calculate or that we establish are conditional on those assumptions. And we call those assumptions and other things that we will see later in other videos, background knowledge. And this vertical bar means given that or conditional on. So basically, what's the probability that the drone will land in the old area, given the knowledge that we have, the background knowledge that we have, or conditional on the knowledge that we have. Yeah, so basically that's the meaning of this notation. Okay, so what's the probability that it will land in an old region? And an old region includes all the striped areas. So it could be here, it could be there. So what's the probability that it will land in this? Well, it is given by the number of people living in this area, and we know that the number of people living in this area is proportional to the size of the land. So basically, because the whole region covers 600 square kilometers, then the probability is 600 divided by 1000, which is the total land of the city, and that's 0.6. Now we can express probability with percentages. We can say 60%. But the most accurate way of presenting probabilities is with a number between 0 and 1. Okay, so what's the probability that the drone will land in the new in a new region? 0.4. So there are 400 square kilometers that are new, So 0.4. What's the probability that it will land in a coastal region? Could be here or could be there. Well, 0.5, because the coastal regions cover 50% of the city. And what's the probability that it will land in an inland region? Same, 50% or 0.5. So because half of the people in the city live in this area. Okay, so one important thing of this metaphor is that we are talking about only one landing. We can potentially repeat and ask what will happen if we consider several landings. But this metaphor gives us an intuition of what's the probability of just one event. What's the probability that the landing will occur in some area? And that's something that is not very easy to get an idea using the other metaphors. That's why I introduced this metaphor. Okay, so this is the end of the introduction of the metaphor. In other videos, I'm going to explain more advanced aspects of probability using this metaphor.